All right, guys. Good morning again. Good morning. Back with me, guys.
Morning,
Students.
sir.
Morning,
All right.
sir.
All right. Good. So we're going to do a little quick revision today, guys. It's always good to keep practicing, so we can stay on top of these things and take the opportunity to try and solidify what we are doing in class, and then also show um, that we are doing the right things in class by bringing up actual exam papers and seeing that we can do those exam questions, right? Because it is always the case that once you can do it in the classroom, you can do it in a session like this, and you can also do it in the exam. Remember also that all examples that I am doing now, you are to go and do. So persons who did the questions already, if you find that you made a mistake, you did something not incorrect, you should go and redo the questions. At least the video will be there now to help you. And if you did not do the question, you need to do it. You have to keep practicing. You have to keep practicing. We're moving on to new material come tomorrow. From tomorrow, we're moving on to new material in class. All right, and we don't want to have any gaps in the knowledge. All right, so this on the screen is the classwork that we did this week. All right, and it gave us a diagram right here. It's a graph. This is a graph of this function, and in particular, this is a curve. All right, it's a smile-shaped quadratic curve, and you can appreciate that because this function would relate to a smile-shaped graph. And this question is a knowledge-based question. It's testing your knowledge of key features of a quadratic function. All right, so the question says we have to determine the coordinates of these points A, B, C, and D in the diagram. A, B, C, and D. Determine the coordinates of those points, and then we are to give a name or phrase which is used to describe each of those points. And then after that, here we're required to write down the name, and the equation of the vertical line. That's this vertical line here, passing through B. All right, so this question is really a test your knowledge kind of question, and also to see if you know how to find those critical features of the quadratic function. All right, so the function they gave us is this one right here. This one, right? And they want us to tell them the points A, B, C, and D. So I'm just going to name them and then work out the coordinates for each one. So the first point is this one, A. And that clearly is a y-axis intercept. So the function is f of x equal, what is it? 2x squared minus 5x plus 2. Then on the y-axis will always carry coordinates 0, c, where the c is the constant in that function. Now why is it that? Because on the y-axis the x value is 0. So the x value, if you know the x value is 0, you plug 0 here and you plug 0 here in the function. The result is going to be that your y value is equal to 2. So this y value, which is the c value, will be equal to 2. But you can all just know that the y-axis intercept, that's the point A, will always have coordinates 0, c from the standard form. The c is from the standard form. So point A, it's a little bit darker. Right, so point A, we call it the y-intercept or the y-axis intercept. And the coordinates of A is 0, c, which is, okay, right, equal. Coordinates of A is 0, 2. C is a constant value in the expression. All right, that covers the point A. Then we come into the point B. Point B. Now the point B is a vertex, is the vertex of the quadratic graph, and this vertex is a minimum one. So you want to be as specific and as exact as you can. We know it's a minimum, it's a vertex, but remember the quadratic graph can have a maximum, or a minimum vertex. This one is a minimum one, so I'm going to say it's a minimum. So it's a minimum turning point, which is also called a vertex. I'm going to write that, give them everything. It's a minimum turning point, which is also called the vertex of the quadratic function. And then what are the coordinates of this point? Where this one is 0, c, where the c is a constant in the standard form. In our class, we are learning that the point B will have coordinates xt, yt. T means turning point. And so this will be the x value at this turning point, and this will be the y value at this turning point. And we have learned that we can actually calculate these values using a formula connecting the coefficients in the standard form. Alright? So I want to write it down. So the B will have coordinates xt, yt. How do we get xt? Let's work it out here in a different color. The formula for finding the x value at the turning point is negative b over 2a. What is the b and the a? The b and the a, they come from the coefficients in the standard form. So the a is going to be this 2, the coefficient of the x squared, not because it's the first term, it's because it is a coefficient. So the a in the standard form is 2. And what is the b? The b is this number in front of the x, the coefficient of x is given the letter b. So the b in this case is negative 5. And then we're also going to use c. We have used c here already, but we're going to use it again for the yt. This value is c. So the c is a positive 2, which you can just write as a 2. So if we use this formula for xt now, we're putting down this minus first. That's this minus. And write equal. That's this minus is this one. And then the b now itself is a negative 5. So we're going to have to put a negative 5 for the b. And then this minus minus becomes a plus. We're dividing this by 2 times a. 2 times, and the a value right here is a 2. Alright, so it's going to be 2 times 2. And then this becomes a positive 5 over 4. And so we can write that positive 5 over 4. And we can shift this over. Let me shift this over. That's what I got. Shift it over a bit. Let's write this back. So it's minus b over 2a. And this becomes a positive 5. This becomes a positive 4. So that's the x value at this point right now. 5 over 4. Right here. 5 over 4. And we need to know the y value. Again, there's a formula for calculating the y value. The y value at the turning point can be calculated using a formula 4ac minus b squared divided by 4a. Right? So these two formulae will not be on the formula sheet in the exam. If you want to use this method, you have to know the formulae. You have to know both of them. This is not the only way to do these questions, guys. But this is the way that we're doing it in this class, in this program. Alright, so that is it. So we want to put in a value for a, b, and c now in this to calculate the y value that's going at the turning point. So the y value at the turning point becomes 4 times a. What is a? A value is this 2. That's 4 times 2. Put everything in bracket. Times c. The c value is this 2 up here. Another 2. Then I subtract. Now this minus is this one. And then I have to square the b right here. What is the b? The b is negative 5. So it's negative 5. And I have to square it. So you see I'm putting it in a bracket. So I'm squaring the negative 5. And I'm dividing that by 4 times a. That's 4 times, and the a again is this 2 up here. Alright. Alright, so this is 2. Alright, and if you simplify this down, you're careful with your signs. Y value at the turning point becomes, now this is 4 times 2 times 2, that's 16. Minus, that's this minus I've written down first. Then this negative 5 squared becomes a 25, it becomes a positive 25. When you square any number, it comes out positive. So this becomes a 25. Any real number you square comes out positive. Then divide that more by 4 times 2 is 8. Then the 16 minus 25 becomes a negative 9. So whatever the turning point is negative 9 over 8. So this is the value now coming here for the coordinates of the turning point. So I'm going to write it down here now as my answer for B. So B becomes a point 5 over 4, negative 9 over 8. Now notice I did not write these two expressions, these two terms in the vertex form for the quadratic function, which is a into x minus xt squared plus yt. Right? ax squared plus bx plus c can be written in this form, which is called a vertex form. This is called a standard form. And the same way you calculate xt and yt at the top, that's how we calculate them down here. But the question was not asking us to do this. So there's no need to do it. Alright? So that's what we need to understand about this question. If you did that, you're basically giving away time doing it, but you're not getting any marks for it. The question did not ask for that. So that's the point A and the point B so far. Everybody good? Everybody okay with that so far?
Yes, sir.
Yes, sir. Sir.
Beautiful. Then they ask us about the point C and the point D. Now C and D is the same kind of point. They are intersection of the curve with the x-axis. And those points are called the roots. Points where the graph intersect the x-axis, the points are called the roots. And the x values at those points are also called roots. And if you want to find the roots of a quadratic function, the points where the graph intersect the x-axis, just know we have to solve the equation. The equation is when you put it equals 0. Alright, so let's look at it one more time. So we want to find the roots now. Alright, because the thing about the roots, you know that at these 2 points, the y value is 0 because they are points on the x-axis. The y value is 0. And the y value is a function value. So like you're putting this thing equals 0 at those 2 points. At those 2 points, the y value is 0. The function value is 0. Alright, so at those 2 points, this expression must work out to be 0 at those 2 points. When you put that expression equals 0, and we end up now having this that we're using to find the roots, that thing is a quadratic equation that we are solving. And when you solve it, you're going to get 2 x values. One for the C and one for the D. A smaller one for the C and a larger one for the D. The smaller one for the C because C is closer to the y-axis and x values increase in this direction. Alright? So, even if you don't get down into all of that explanation, the bottom line thing that you want to know is that if you want to find roots, you solve the quadratic equation. Whenever you solve a quadratic equation, you are finding roots. The more things you know is the better. The more things you know is the less you have to figure out. So between know and the exam, we are trying as much as possible to arm ourselves with knowledge, knowing stuff. Just know stuff. Like for example, we don't have to go figure out that if you want to find the roots, you have to solve the equation. It is better to just know that, because that is the case all the time. Anything that you can just know as a fact, and it is consistent under all conditions, and you just know that that is how it is, then it means that you don't have to go in the exam and figure out these things. And especially things that CSEC set questions and test all the time. Those are the things in particular that you want to just know them. So as soon as you see the question, you know what to do. Because you're coming from a position of knowledge, you know. There will always be things that you have to figure out, different things. CSEC will set some things on exam paper that sort of different, and that is testing how you apply your knowledge, your application of your knowledge. But then there will always be a lot of things that you just know and just do. Just like how you know, say 2 plus 2 are 4. And you know, say 5 squared is 25. These things you just know, you don't have to work them out. You just know. That's how you want to approach this thing. So just know that if you want to find the roots, you solve the equation. Alright? So that's a level that we want to get to. The more things you know, the better. The more things you know, the better. Alright, so we want to spend the time between now and the exam knowing as much as we can. Alright, there are things we're going to understand and apply, but there are going to be a lot of things that you just need to just know and apply from knowledge rather than just the understanding and figure out. You don't want to have to be figuring out stuff in the exam. It takes time to figure out stuff. When you know something, you don't waste any time. You go straight at it. Alright, so C and D are called the roots. The roots. That's one phrase that can be used for those 2 points. They are also called the x-axis intercepts. Because they're the point of intersection between the graph and the x-axis. Intercepts. So any of those you wrote for the name or phrase for those 2 points, you get the marks. And then to find it, you solve the equation. To find the coordinates, you solve the equation. To find the coordinates of the points C and D and the coordinates, you already know that the y equals 0 at these 2 points. You already know that the y equals 0 at these 2 points. The y is equal to 0 at those 2 points. Or you get the x-axis, you solve the equation. We're going to write and 2x squared minus 5x plus 2 is equal to 0 at these 2 points. So y is equal to 0 at those 2 points, and this is equal to 0. The quadratic expression is equal to 0 at those 2 points. So when you solve this, you're getting the x values to go with the y values at those 2 points. And then we can solve this by factorizing the factorization process to solve it. Or we can use a quadratic formula. Some persons factorize it and some persons use a quadratic formula. It is already in the standard form because we have the expression equal to 0. So we can go ahead and solve it. Alright, I'm going to factorize it this time. Let's remind ourselves of the process of factorizing, even though there's a factorization question that we'll have to do. But let's do it still. So I'm going to factorize this expression. We want to split out this middle term, remember. And so we call it the AC method because the first step is to multiply the A and the C in the expression. So multiplying 2 times 2, that's the AC. Multiplying 2 times 2. 2 times 2 is 4. Then this 4 is the AC. You want to split it so that you want to find factors of that 4 that add to this middle term of negative 5. That's what I want. Factors of 4 that add to negative 5. Alright, let's read it out now. We're searching for the factors of 4 down here that add to negative 5. Now, 4 is a positive number. And we want factors of 4 that add to a negative number. Factors of a positive number like 4 is either 2 negative numbers or 2 positive numbers. Since you want the sum of the factors to be negative like this, you have to use 2 negative factors of 4. The first two factors of 4 are 1 and 4, and you have to make both of them negative. So they multiply to give you this 4. But when you add them, you're getting the negative 5. So you have already found what we need. We have already found what we need. So this adds to the negative 5. So yes, we have already found the factors of 4 that add to negative 5. It means that we're going to split this 5x using the minus 1x and minus 4x. That's what we use those factors to do, to split the middle term. I can put the negative 4x in front of the negative 1x, or I can put the negative 1x in front of the negative 4x. It doesn't matter. Alright? All we know now, we're going to split this thing. So this thing, we're going to split it. Let's do it down here. Remember, we're trying to find the x values for points C and D. We're using a factorization method to solve the equation. So we now have 2x squared, and this now split out into minus 4x. That's from this one, and minus 1x. I could just put minus x. That's from this one. And you must always check that when you split the middle term into right here, would give you back that middle term there, which they would. Minus 4 minus 1 is negative 5. And then this term comes back down here unchanged. So that's a plus 2, and it's all equal to 0. We'll just need to factorize these two and factorize these two such that we have the same thing in the bracket. Same thing in the bracket. Same thing must be in the two brackets. So we're done. Factorize the two parts. Alright, remember that. Same exact thing. So we'll go for the first two terms, and we'll go for the highest common factor in the first two terms. The highest common factor of these two values, or these two expressions, is 2x. We'll factor out the 2x. If we divide 2x out of this, we factor in an x right here. If we divide this by the 2x, we're left with a negative 2. And as I said, because I need to have the same thing that I have here in the bracket over here, I prefer if you just put back the same bracketed term over here first, x minus 2. Then I want to look from this, what I factor in here to determine what I need to factor out here. Remember, out here you must have a plus value or a minus value. Out here I'm talking, you must have a plus value or you must have a minus value, not just a value. Alright, I'm talking about what we factor in out of this to get this. Two ways to do it, to get the value for out here. We can divide this positive 2 by this negative 2. That will be negative 1. Or we could divide this negative 1 by this x. Negative 1x by this x. So in any case, this is going to have a negative 1 out here. That's all equal to 0. And then now, x minus 2 is a common factor, and they are connected with the 2x minus 1. 2x minus 1. So we're going to connect them into one multiple. So it becomes 2x minus 1. That's this and this. Multiplied by the common factor of x minus 2. That's all equal to 0. Then now come to the product of two expressions equals 0. So either this expression is equal to the 0. What will be the x from that? We'll have to take this negative 1 and carry it over, make it into a positive 1, and then take this 2 and divide under it. Like that. So the x is going to be equal to half from that factor. So from this factor, if this factor equals 0, the x is a half. And if this is a factor that is equal to 0, we will just take this negative 2 and carry it over the equal sign, becomes a positive 2. So x is equal to 2. So these now are the two x values at the roots. That's what we just found. That's how we found them by solving the equation. Right? So the smaller one, which is a half, is at D. So this one is at C, sorry. And the larger one is at D. But the question asks us for coordinates. This word, coordinates. Coordinates must always be written bracket. I put in the x value and the y value, both of them. Coordinates is a plural word, so the big S on it there. Coordinates. Alright, so we have to write the points in coordinate form, which is C as an x value of half and a y value. See there? C and D have a y value of 0. And then D has an x value of 2 and a y value of 0. So that's the points C and the point D. Points C and D. That is it. Want to go to that?
Yes, sir.
Sir.
Yes. No question? Nobody have any question? Nobody good? All right, beautiful.
Yes, sir. I understand.
All right, beautiful, beautiful. All right, so keep the understanding now if we go and practice and redo the question and all of that, right? The next part is asking us about this vertical line that passes through the turning point. That line is called a line of symmetry or an axis of symmetry. It divides a graph, the quadratic function graph, half and half, such that this half is a mirror image of this half. Where this is like the mirror line between them. And it is such that the y values or the x values or the x coordinates is the same distance. For the same y value, the x values are the same distance from that line of symmetry. Alright? And it happens on the graph, and it also happens in the table. You can pick up where the line of symmetry is even in a table of values. Once the x values are evenly spaced, you can pick it up. Alright? So let's talk about that vertical line now, which is another critical feature of a quadratic function graph. Vertical line through the turning point. Vertical line. Well, this vertical line is called the axis of symmetry. That's the name of it. The symmetrical line, or you can call it line of symmetry. I'm going to spell symmetry with 2 M's this time. Sometimes you see it spelled with 1. The American spelling is 1, English spelling is 2. But that's a line of symmetry. And the question also asks us to write down the equation. The equation of that line is always x equals whatever the xt value is. That's how the equation of that line is written, a vertical line. Why is that? Because it's a vertical line that passes through a point where the x value is that, xt. And vertical lines will always have an equation, x equals some number. That's how vertical lines equations go. What do we get that number? The x value at any point that it also passes through. Alright? So that's why we have it as x equals xt. And xt in this question was 5/4. X value at the turning point is 5/4. Where is it? See there? X value at the turning point B is 5/4. So a vertical line then is x equals 5/4. That is it. X equals 5/4. That is the equation of that vertical line, axis of symmetry line. Very good.
Yes, sir.
Right.
Yes, sir.
Let's move on to the next questions then. So this next question is asking us to factorize completely this expression and this expression. Alright? Alright, let's do this one first. So it's 4 terms there, so we know it's a factorization by parts and factorization by grouping. Right? When you see 4 terms like that, that's the type of factorization that I get. Again, you want to know the types of questions that you can get. So when you see it, you know exactly how to approach it. You don't have to be figuring out how to approach it. Right? NT. So we want to factorize these 2 terms and then factorize these 2 terms so that we have the same thing in the bracket again. And so that's the approach you want to use. So what you're going to do is look at these first 2 terms and say what I would factorize. I would factorize the 3. Just thinking ahead before you start, you know. Because I want to decide if I need to rearrange the values. That's what I'm trying to figure out. In these 2 terms, the common factor is 3. I would end up with g minus t in the bracket. So I'm going to look. Is the g term first in the second 2? Yes. Is the t term second in the second 2? Yes. It means that since you have those conditions, it means then that the values are set out in a friendly manner already to allow for a nice, smooth and clean factorization by parts. So we'll proceed. Highest common factor in the first 2 terms is 3. 3 divided out of that is g. 3 divided out of this is negative t. What did we say? Put back the bracketed term over here first. G minus t. You can look, how do I go from plus 2m to this g being here? It means that I have factored out plus 2m down here. And you can check it because plus 2m times this is equal to that. And also plus 2m times this negative t is equal to that. So you can always just do a quick rough check as you go. Alright, and then now g minus t is a common factor. The question says complete, so you can't stop there completely. So this becomes a common factor. And those 2 common factors are connected with the 3 and the plus 2m. So we're going to just connect them and factorize it fully. 3 plus 2m times the common factor of g minus t. And basically that is it. If you do it and get the g minus t in front of the 3 plus 2m, that's still correct as well. Alright? So don't worry about it. But good at that? But
Yes,
okay?
sir. Yes, sir.
Beautiful. Next one is this. Question wants us to factorize that one. Alright? Remember, you must know the type of factorization that you get to do. Now, that's a quadratic, you know, but it's not a trinomial quadratic. So we're not going to use the AC method on it. It's not the 3 terms quadratic. It's a 2 terms quadratic. And we can clearly see a common factor of 3 off the bat. And when you're doing the factorization and there's a common factor, you must always do a common factor first. Right? When you see a common factor, you get something to factorize, and there's a common factor in it, and all the terms, yeah, a good kind of safe rule to do a common factor first. Alright? So that way, you end up factorizing it completely by the time you reach the end. Alright, so we have 3x squared minus 3. See a common factor of 3 in there first. 3 into 3 out of this 3x squared, leaving with x squared. And then this divided by this 3, leaving with a negative 1. And some person in class stop there. We have to realize that inside it can be factorized again. Because it becomes now the difference of 2 squares. Because why is it difference of 2 squares? Because 1 is the first square number. People tend to forget about number 1 as a square number, but 1 can be written as 1 squared. People always identify with 4 and 9 and 16 and 25 and 36 and 64 and so on. But people always forget about 1. Yes, 1 is also a perfect square. And we want to apply this rule for the difference of 2 squares. A square number minus another square number becomes the difference of the 2 numbers without the square times the sum of the numbers without the square. Let me shift this over. Run out of space. Let me shift it over a little bit. Alright, so it becomes a plus b. So the difference of the number times the sum of the numbers. Alright, so what to apply this? So this then is going to be like the a, but this one is same as 1 squared. So I'm going to write this as 3 bracket x squared minus, and write this one now as 1 squared. Because I'm trying to set up this so that I can apply this. Alright, so this is like the a now, and this is like the b. So this becomes 3 times. Notice I'm keeping the first factor, alright, which is a 3. And this inside, factorizes into like a minus b really becomes x minus 1. And a plus b over here really becomes x plus 1. And then no part of this can be factorized any further. And so that is it. We have completed those factorizations. But okay with that?
Yes, sir. Yes, sir.
Alright, good. Then we come to this last part, It tells us to solve this equation. It's a quadratic equation, just that it is not yet in a standard form. Standard form is when you have 0 alone on the right side. But we have a 6 over there, so we need to get the 6 over here. And it tells us to solve it and give the answer to 2 decimal places. Now, this is like a hint to use the quadratic formula. X equal minus b plus or minus the square root of b squared minus 4ac all over 2a. It means that we won't be able to factorize it using the AC method that we learned to get those integer values. It won't be able to be factorized using that method. Alright? So this telling us to use the 2 decimal places, basically saying the answers are not going to be exact. Right? And so you won't be able to factorize it using this factorization method that we have learned. And so you're going to have to use the quadratic formula. It's like a hint. So it makes no sense to waste time trying to use factorization method on this. Alright? So remember that, guys. So the equation they give us is 3x squared minus 5x equals 6. I'm going to put it in standard form by transposing the 6. So it becomes 3x squared minus 5x minus 6 equals 0. And we're going to use this formula. We need to know the A, the B, and the C. So let's write them down from now. So the A is equal to 3. Coefficient of the x is 3. The B is equal to this negative 5. Coefficient of x is negative 5. And the C is a constant term with the sign on it, which is negative 6. I plug in those values in this formula. Let's write the formula again, back in blue. So the x is equal to minus b plus or minus the square root of the b squared. I took out the 6. And b squared minus 4ac. And the key thing is some people put in the 2a over here, which is wrong. Remember, it is everything that must be on the 2a. Everything over the 2a. Everything over the 2a. It's very important. Everything must be over the 2a in the formula. Alright, so the x becomes equal to minus, that is this minus that I just wrote down. And what is the b? What is the b itself? The b itself is negative 5. So to put a negative 5 in the place of the b now. So this minus becomes a plus. Then we put in this plus or minus. The plus or minus is that they're going to get one x value with the plus and the other x value with the minus. That's why we have the plus or minus in that formula. Square root. And then this now, we're going to square the 5, the negative 5. The b is negative 5. Negative 5, and you're squaring the entire thing. That's how you write it. Some persons did this. And then put it in the calculator, you don't get the wrong answer. Because you put it in the calculator is going to see the square only on the 5, which is wrong. This is the negative 5 that is squaring, the entire negative 5 that you're squaring. Then put on this minus, or this minus 4, I should say. Then the A is this 3 right here. Then the C is negative 6. And remember, you put in everything over 2a, 2 times a. It becomes 2 times the a is 3. The a is this 3 right here. Alright, and let's simplify that down. So x becomes equal to, now this minus 5 becomes a positive 5, or that's 5. Plus or minus the square root. And when I square this negative 25, it becomes positive 25. I'm just going to write 25 there. Then I'm multiplying out this now. And careful with the negative signs. So this negative 4 times negative 3 becomes negative 12. Negative 12 times negative 6 becomes a positive 72 plus 72. Negative times negative is positive. They're dividing all of that by 2 times 3, which is 6. Let's simplify again. So the x becomes equal to this 5 out here, plus or minus the square root. 25 and 72 is 97, and you divide that by 6. So can I write the two roots now? The first one is 5 plus square root of 97 over 6. And the second one, let me make this smaller. Second one, so we can say or x equal 5 minus root 97 over 6. Then put in those values in the calculator, and I want you to have those textbook display calculators so you can type it in exactly as it is. And I think the first answer was 2.47. I'm not going to show it on the calculator this time. When you work this out with a calculator, and this one is x equals negative 0.81, I think. We work that out with a calculator. Those are the two values. Some person put 2.48. Alright, not bad. Because I worked out this part first before they divide by the 6. But we'll talk about how to correct the best way to calculate that data some other time, not now. But that was the classwork, guys. Nice and easy. But it goes so far? But
Yes,
okay?
sir. Yes, sir.
Good, good, good. So remember, if you never get it right, then go and do it again. More maths equals better maths, alright? Alright, so the papers that I sent you to practice from now, let's get to those now. What did I do here? Let's get to those now, right? Let's get to those things that I sent for you to do. So I don't remember the order in which I sent them. But I know that I sent this one. Alright, I know that I sent this one. Let me look and see. Let me look and see which one I sent. I don't remember the order that I sent them. Let's see quickly. Let's see quickly. What I sent for you. I do them in the order that I sent them. The first one I sent you was on January 2022. Yeah, this is it. That's the first one I sent you. You saw? That's what I'm seeing here. January 2022. Which question did I tell you to do? Just that question, number 8. Alright, guys. So this is what I told you to do. Alright, so let's go. So these are exam past paper questions, very, very recent exam. So it means that, these are the kinds of questions that you will get in exam. That's a quadratic question. So they give us this function, that's just another way of writing this. And as I said, I could also put y equals 3 plus 5x minus x squared. It's a quadratic. Now, as soon as you see this quadratic expression, or a quadratic function, because the square term is negative, you must know that the graph has a round shape. And also, this is your C. So this is where it crosses the y-axis. As soon as you see it, you must be, be mindful of that. The question wants us to complete the table. See? Complete the table, meaning you have to fill in these values. 4 of them. Now, I can fill in these values without doing everything by observation. Right? And then I can calculate and show you. Why am I able to do that? Because I know that the values are symmetrical about a line of symmetry. These values are symmetrical about a line of symmetry. Once these are in the same equal interval from value to value. So you see, they're all going up by 1. Negative 1 go by 1 to 0, go by 1 to 1, go by 1 to 2, then 3, then 4, then 5, then 6. The quadratic graph is a symmetrical graph. The y values are symmetrical about a line of symmetry. And I can observe these two values inside here. What that means, is that the value inside here is going to be the same as the value inside here, because the values are symmetrical. Alright? And then if I go to the right of this one, look, if I go to the right of this one, I get to this 3. When I go to the left of this one, this also must be a 3. And then it's a different color. If I go to the right of this 3, it must be the same value as going to the left of this 3. So if this is a negative 3, then this also must be a negative 3. So those are some values I can know already. Let me erase these boxes and so you can see. So those values I can write down without calculating. Right? So the only two that I don't know by observation, by looking, are these two. Because these two must be the same. If you look at the symmetry of the values. Symmetry of the values. These two in the box must be the same. And my line of symmetry is going to be right between here. So, right here. My symmetry is right in between here. And 9 cannot be my maximum value. Because the maximum value occurs at a vertex, which is a single point. The maximum value is a single y value at a single point on the graph at the vertex. So the 9 cannot be my maximum value on this function. I know it's a maximum because the x squared term is negative, so it's going to frown. When it frowns, it is a maximum. So the 9 and the 9 are on either side of my maximum point in there. Some things you can use your knowledge and do. You don't need to calculate everything. So if I use the 1 to calculate this value, I can just put that same value here because of the symmetry of the values. Not everything has to be calculated. But let me ask you a question before we move on. Do you guys understand and see why this negative 4 matches this negative 4? Negative 3 matches that negative 3 because they are the same distance from this line of symmetry in the middle. And also, this 3, since this value is 3, then same distance on this end is 3. And you can see that 1 unit from the line is a 9 this way and a 9 that way. So if you notice now, to this box, to the right, is the same distance from the line of symmetry to this box. So those two values are going to be the same. Alright? But I'm going to work out all of them and show you, but I'm telling you that I could deduce them by observation. So I know that in this box, I need to put 1 in the function there. So let's work it out for you. Let me work it out for you. So this box is where x equals 1 in this box. Right? Let me do it down here for you. I have space to do it. Let me do it right under it then. In this box, x is equal to 1. So when x equals 1, I want to find the y value. I put it in this function right here and there. Right? So the function value is f of 1. Or I can say the y will be equal to, put it in there, 3 plus 5 times 1 minus 1 squared. That's what I put when I plug the 1 in this. Right? So the y value at that point, this works out to be a 5. That works out is a 3. That's 8. Minus this 1 squared is 1. 8 minus 1 is 7. So right here, the value is 7. And put down in blue. I'm telling you that this is going to be a 7 as well because of the symmetry. But let's say I didn't know that that's going to be a 7 as well. I'm going to calculate it for you and show that it is 7, this point right, the value right here, by plugging in x equals 4 in the function, x equals 4. Put it in this function and work it out and show you. So if x equals 4, the y value using this function is 3 plus 5 times 4 minus x squared becomes 4 squared. Let's work it down. Y equals, now this becomes 20. This is 3. So that becomes still 3. Write them out. 3 plus 20. This 4 squared is 16 minus 16. See there? 20 minus 16 is 4. 4 plus 3 is 7. So you see I get the 7. I did not have to calculate it. I could use the symmetry of the values to know that this is a 7. But I go to that. I'm going to work out all of them for you now. So I'm showing you. Having worked out this one, I did not need to work out that one. So in this question, the only one that I needed to work out was this one. That is the one. I could know this value from this. And I could know this value from this. Because they are symmetrical. And then I would know this 7 after I work out this one. So there's only one value in this question I really need to work out, which is this one. But a lot of persons will work out all of them, and you don't need to work out all of them because the function is symmetrical. See, questions are complete. 2 marks for it. Yeah, I could say something like the values are symmetrical about this line, and so I could deduce the values. But if I were to work out this one, just to show you, just to show you, the only reason I'm working them out is just to show you. If I were to work out this one, right, it is where x equals 0 in the function. And if x equals 0 here and there, then clearly the y is going to be 3. Right, so we could write it down here still. So y, that's on the y-axis intersect. So the y value will be 3 plus 5 times 0 minus 0 squared. All of this gone because it's zeros. So the y equals 3. So the 3 there. And then for this one out here, it's a matter of plugging 6 into this function. But I didn't have to work it out because I know it's symmetrical out from that negative 3. But if you put 6 in this function, you will get it. Let me put it up here for you. So these additional calculations are not necessary. The only one I would maybe calculate is this one. The only one. The rest of them, I would not need to calculate. I want you to learn it that way. Learn it from a symmetry of the function, the knowledge of the symmetry of the function. You don't have to waste time working out all these 4 values. It's time you're wasting working all of them out. You can get them from a symmetry of the values. So at this point, the x equals 6. So the y would be 3 plus 5 times 6 minus 6 squared. Alright? Now, this should be 3 plus, this should be 30. Minus, this should be 36. So 30 and 3 is 33. And then 33 minus 36 is negative 3. So that's what it will be. But again, these don't have to be worked out. This is the only one I would work out. And then deduce the rest of them. Understand what I'm trying to explain to students? Understand what I'm trying to say?
Yes, sir.
Alright. But for the purpose of the graph, the question is going to ask us to draw the graph, you know. Right? See there? It gives us these points and the one on the graph. But the point that is missing is a vertex. And you must know that the function has a vertex. We can calculate the vertex using x, t, y, t, using the a, the b, and the c from that. But you don't have to calculate it because the x value at the turning point is equidistant between those two values, between 2 and 3. Halfway between 2 and 3 is 2.5. The axis of symmetry is on this line. This red line. This red line divides these y values equally to the left and to the right. So that represents where the axis is and what the vertex is. Remember, the axis passes through the vertex. Halfway between 2 and 3 is 2.5. So I can tell you that the x value at the turning point is 2.5. Without doing any calculation, that's the average of these two. Halfway between 2 and 3 is 2.5. And then if the x value at the turning point is 2.5, I can put this 2.5 in this function and work out the y value at that point. So the y value at the turning point will be put 2.5 in this. It will be 3 plus 5 times 2.5 and minus 2.5 squared. Let me shift this over some. Minus 2.5 squared. So the y value at the turning point will do what? What is that? Maybe that is 9.25. Let me see. Let's calculate it. Let me just calculate it on my phone. Right here. Or somebody can calculate for me. Something higher than 9. I think it's 9.25. Alright, so it is 3 plus 5 times 2.5 minus 2.5 squared. See there, 9.25. It means that the maximum turning point has these two colors. I'm going to put this part in a different color. Put this part in a different color, in purple or something. Then put all of this in purple. Because all of this is relating to the vertex. Put all of this in purple for you. Let's change it to purple. All that relate to the vertex, the turning point. Right? It means that the vertex xt yt is 2.5, 9.25. That's where the vertex is. Right? So the vertex at a maximum point is a maximum point. Maximum point on this graph. You know they didn't put it in the table. is 2.5, 9.25 xtyt. So this question, you want to know that kind of stuff, that it has a vertex point. And you have to include a point on the graph, even though it's not in the table. You still have to include it in the graph. So I'm going to come around to the graph and put it on. So the 2.5 line here, so that's the line of symmetry right here. We'll work for the red. Right between the 2 and the 3. X equals 2 and x equals 3. This is the line of symmetry. You can put it in from now. All the values will be equidistant. The y value will be equidistant from these two. From this line. The line of symmetry, or the axis of symmetry. That's my line of symmetry right there. Corresponds to the red line, or the vertical line that I drew on the table. Corresponds to this line. Right between the 2 and the 3. So this is 9, you know. This is y equal 9 up here, so, you know. Those 2 points here, y equal 9. Those 2 points are for these two y values. 2, 9 and 3, 9. So the 2.5, 9.25 is right between them on that red line. So I'm going to estimate where 9.25 would be. And I'm going to mark it in purple or mark it in blue. I need 9.25 on this line. So it's a 9 here, so it's a 10 here, so let's zoom in on it. So this is 9. This is 9. And it's 10. So 9.5 would be halfway here, so that would be 9.5. And halfway between 9 and 9.5 is where 9.25 is. So 9.25 will be maybe about here. 9.25. I'll put another way. This is 9, 9.2, 9.2, 9.4, 9.6, 9.8. So if I zoom up, this is 9.2 and this is 9.4. So in between them is 9.3. Alright? And so 9.25 is even right here, so if you want to be even more precise, this is 9.25 that I'm drawing now. 9.25. That's 9.25. Use a different color for the 9.25 line. Use a different color. This is 9.25. Between the 9.2 and the 9.3 is 9.25. That's where the maximum is on. So you come across this on a graph right above the 9.2 is a 9.25. So this point right here, put a different color in blue. That point right there is your maximum turning point. Right? That point. This point is 2.5, 9.25, or 9.25. If you use xt and yt and calculate it, you're going to get the same values if you want to try it. That's the maximum turning point. Alright, and then now we can put in the other points at the left out. Alright, so the points that they left out, see if they give us negative. And I can look at what we have and work them out, you know, but the point that we calculated was 1.7. That's the only one that we calculated, 1.7. Let me put that on, because the others we could figure out. If we can figure it out on the table, you can figure it out on the graph as well, because you can use the line of symmetry as your reference. So that's the only one that we calculated, that we had to calculate. So 1.7 is a point, 1.7. So 1 year, so 7 years, so 1.7 is right here. 1.7. Alright? Right there, 1.7. I'm gonna put the x there as well. 1.7 is right here. Now, if this is 1, 2, 3 to this line, then there's also a 7, 1, 2, 3 on the other side. So there's a point here as well. See, that point is 4.7, and we did get 4.7 on the table. 4.7, see there? 4.7. So I'm telling you, you can figure out all other points by using the red line as a symmetry, as a line of symmetry. So this one, for example, is an equivalent point on this line, on the other side of that line. Look, 1, 2, 3, 4, 5. There's one point like this, 5 on the other side. 1, 2, 3, 4, 5 on the y-axis. See, that's the point 0, 3 now. 0, 3. See there, that's this point 0, 3 on the y-axis. So I'm just showing you this way, so to enhance your knowledge. The more things you know, the better. Which other point? Then you have this point down here. 1, negative, 1, negative 4. I can see how far over on this side this equivalent point is supposed to be. Right? So 1, 2, 3, 4, 5, 6, 7. There's 1, 7 on the other side. 1, 2, 3, 4, 5, 6, 7. There's a point here. That is 6, negative 4. Let's look for it on the table. 6, negative 3, sorry. 6, negative 3, that last point that we just put in a while ago. Equivalent to this negative 1, negative 3. Here. This is negative 1, negative 3. This is 6, negative 3. So you don't have to be running to the table to find some of these. You could use, put in the red line as the line of symmetry, and then you can count off and find other points. So you want the graph passing through all these points now, guys. Remember, you must carry it up to this point. I'm just going to draw it now. So I'm going to come down on one side over here.
Sir?
Yes? Have a question? You asking a question, youngster? No? Come down over here as well. So some people did this question and did not draw this point. And what they did, they came right across here. Come up to this point and go straight across here to this point. The quadratic graph don't have a straight line on it. It's a curve. All throughout is a curve. And you have to remember that it comes up to a maximum point. So anybody who did this and didn't work out this point up here, that vertex point, I want you to redo the question for me. Please do it over again. Everything important. That's why you improve and get full understanding of this thing. But that is a curve. That is a curve. And I think they ask us a couple questions on it. Like here it says, write down the equation of axis of symmetry. It's x equal whatever the x value turning point is, 2.5. So you see, you had to know this 2.5, that red line. X equals 2.5. We're talking about this line right here. Axis of symmetry. X equals 2.5. Vertical line through 2.5. So you see, then, tell if you calculate x or not like that, But you had to work out, you had to know that that is that line, and that's the equation of it. X equals 2.5. State the maximum value. Is a 9.25, 9.25 or 9.25. That's the maximum value. If you want, you can calculate yt and you get that. If you calculate xt, you're going to get that. So you could have calculated them as well, but I'm showing you that sometimes you don't need to calculate all of those things. You can figure it out from the information that you have. But everybody good at that? If you want to calculate x and calculate yt by yourself, you're going to get these same values, xt and yt. Everybody okay?
Yes, sir. Yes, sir. Yes, sir.
Good. And I say you must keep out this part. I didn't want you to do this part, right? Leave out that part. So I don't want you to do for this question. Alright, let's look again. What time is it now? Alright. 12:20. I want to finish a couple questions that I gave you in the class to do. So let me see. Supposed to be another one in there. So let me see. That one. Here's another one. With some factorizing. Alright, so I gave you this to do as well. This is 2015. Alright, so this is number 2 with some factorizing to do. So this question says we have to factorize this completely. Factorize this complete. This question was kind of tricky when I set it in the exam, right? Okay, we look at these two terms right now. Just have a common factor of a first. So the common factor in this is just a. So I factorize out the a. I'm going to be left with a squared from this one minus, this is just a 12 that is left if I factor this a. I think a lot of people would stop there now. And CSEC might give you the marks for that. But this actually can be factorized as the difference of two squares. I can turn this into a perfect square, this 12. By doing what, Mr. Shaw? By square rooting it and then put back a square on it. Look carefully. I feel like anybody who stop here is going to get the 1 mark, But I'm going to go further with it and show you. Alright? So this I can write as the difference of two squares. And I can turn this into a square number by square rooting it first and then square it back. So I'm going to write this as a bracket a squared minus, see it here now, I'm going to square root this first, square root of 12, and then square it back. And now I have the difference of two squares inside here. So I can apply the rule. It becomes this a factor out here first, and then this is the difference of two squares. It's going to become a minus the square root of 12, a plus the square root of 12. But I really think anybody who did this would get the 1 mark. This one. But it could have gone down to that way. I think anybody did this will get the 1 mark. But it could have gone down to that. Using that method. I don't think CSEC wanted it to do this thing. But I write with that. But okay?
Yes, sir.
Alright. And this one now wants us to factorize a quadratic, trinomial with 3 terms. So again, I want to split this middle term. Now this can be factorized quick and easy, because the n values are prime numbers. The only factors of 2 is 1 and 2, And the only factors of 3 is 1 and 3. So these are the values that must end up in the 2 brackets. 1x and 2x and factors of the 3, 1 and 3. So these 2 values here has to be 1 and 3. It's a matter of where you put them. But I'm not going to get into that now. When you master the process, the AC method, I show you the quick way of factorizing expression like this. It's a lot easier when the n values are prime numbers. But I'll deal with that another time. Let's look at the process method to split this. So the AC is 2 times 3. 2 times 3, which gives you 6. Factors of 6 that add to the middle coefficient of -5. Factors of 6 that add to -5. Now factors of 6 has to be either 2 positive numbers or 2 negative numbers, because 6 is positive. Since we want the sum to be negative, we need 2 factors, 2 negative factors of 6. The first 2 factors of 6 is 1 and 6. The key thing is to remember that both of them must have the same sign. But when you add these, you get -7, which is not what you want. You want -5. So the next 2 factors of 6 is 2 and 3. Make both of them negative because you want the sum to be negative. And these actually add to the -5. So yes, you have found it. You want to split this -5x into -2x and -3x. Alright? So this then becomes 2x squared, and then this split out into -2x, -3x. So this comes from this one, and this comes from this one. Alright? And then we'll put back this +3. Put a line down here. And then now we're going to do the highest common factor in the first 2 terms here. So it's 2x. 2x out of this leaves with an x. 2x out of this leaves with a -1. And you must put back the same thing in the bracket over here. X minus 1. Anything that's in the bracket here, put it back in there. You must have the same thing in the bracket. Then now in between here must be a plus or minus a value. So if you look at this, If the x is factored in, then the minus 3 is factored out. Another way to look at it, or get it, is to divide this 3 by this negative 1. 3 divided by negative 1 is negative 3. You have this common factor now of x minus 1, and they are connected with the 2x minus 3. So let's go ahead and connect them, the common factor. So it's 2x minus 3 connecting x minus 1. And that is it, that factorize it completely. And that finishes that question. But alright? Very good?
Yes, sir. Yes, sir.
Alright. There's another question on this paper I wanted you to do. Number 8 or so. No, number 4. I told you to do this question. Did I tell you to do this question? Number 4? I don't remember.
Yes, sir.
Yes, sir.
Yes, sir.
Alright,
Yes, sir.
Alright, so we have to do this one, and the graph is there. Beautiful. Alright, good. So we're going to do this one and then we'll call it a day, right? I don't like when the Saturday class is too long. Alright, I don't want them to be too long. I don't want to just keep the focus and you remain interested right through. I don't want you to get tired or bored or anything. So I don't want the Saturday classes to be too long, 2 hours the most. All right, let's see. This question says, the table below is designed to show the x and y values for the function. This is a quadratic function. All right, and it's for integer values from 2 to 4. Integer x values from 2 to 4. So these are the values. Those x values, and I like to check that the values are the same interval because I'm looking for the symmetry of these values. But for the symmetry of these values to work, these values must be going up by the same amount each time. In this case, let's say we are going up by 1. Let's go 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 by 1. Let's go by 1. Let's go by 1. Good. So the values are in the same interval. So these values must be symmetrical because they're on a symmetrical graph. All right, let's work out the symmetry of the values. All right. So I say these 3 values, the negative 3 and the negative 3, they are on either side. So this is the axis right here now. This represents the axis. The axis is on right here. That's the minimum point right there. So no. Axis is right here. So that's the vertex coordinates right there. So the values are symmetrical about this cell. You can see it right away. And you can see it because 2 blocks over you get to the 5. 2 blocks over you get to the 5. So it means then, whatever value I work out for this box, the same value going in this box. So I don't need to work out both of them. I only need one. See? It's the same value must be between negative 3 and the 5. Negative 3 and the 5. Right? So I know before doing anything that this is my minimum point. This point. Negative 1. Negative 4 is my minimum point. But let's work out this one and then put the same value over here. Let's work out this one. So this one is when we put in x equals negative 1 in this function. So if x equals negative 1 in that function, then the y is gonna be negative 1 squared. That's negative 1 squared here, so minus 2 times negative 1. That's right here. And then minus 3. So the y is going to be, this negative 1 squared is a 1. Then this negative 2 times negative 1 is a plus 2. And then this negative 3 comes back. So this actually works out to be 0. This y value is 0 right here. And so this y value is also 0. Remember now, at the points where the y value is 0, that's on the x-axis. On the x-axis, y value is 0. So it means that these are the roots. These are the roots, you know. These are the root points, root coordinates. So this is on the x-axis. So these are roots. Our root and root then. Those are the 2 roots. So negative 1, 0 on the x-axis is a root. Negative 3, 0 is another root on the x-axis. So those are the 2 points of the graph intersect the x-axis. right? You see this one is a y-axis intercept. So the x value is 0, or is the c value negative 3 in the function. So this one is your y-axis intercept. So you can know these things. It becomes easier the more things you know. Alright, so those are your points. Alright, the question wants us to draw the graph. And we're going from negative 2 to 4. So we're going to have to put in our axis ourselves. And then also put in the y-axis. So notice that the lowest value is negative 4 and the highest value is 5 on the graph. So I've kind of draw the graph so that it can fit all those points in it. Alright, so we're kind of be smart in scaling up your graph. So you can, for example, go now and put your use blue for the scale. You can go put your axis down here, so you're not going to capture everything. You can put the origin down here, so. Alright, so lowest value is negative 4, highest value is 5. So let's say on the y-axis we're going to interval. We can work it out now. So let's say we put it so that our minimum point come down here. Negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. It's going to be 2 now, so you can space it out some more. Let's see if we go negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Not going to work. So we're going to use 1, but we do have to come all the way down here. So let's put it like that. Let's put this at negative 4, negative 4, negative 3, negative 2. I'm just going to sit in where I'm going to put the axis, right? Negative 1, 0, 1, 2, 3, 4, 5. So that's my vertical axis. Then horizontal axis now from negative 2 to 4. Negative 2 to 4. Right? The question about, oh, give us a scale. The right give us a scale now. It says 2 centimeters to represent 1 unit on the x-axis and 1 to 1 on the y-axis. Alright. So it kind of give us a scale. So it's the same scale I'm using. So horizontally, we're going to start the negative 2. Let's say we start the negative 2 here. So negative 2, negative 1, 0, 1, 2, 3, 4. Good. Alright, so my vertical axis is going to pass through 0 and my horizontal axis is going to pass through this 0. Just like that. So my vertical axis is going to pass through this 0. So this is my vertical axis, my y-axis. Passing through that 0. So my y-axis passing down here. I can't draw a straight line with this device, guys. My horizontal axis is going to be here. My x-axis. I can scale it up now. Let me scale it up. So this is my x-axis and this is my y-axis. And this is 1. See there? 1. Right here says 1, 2, 3, 4. And this is negative 1, negative 2. And then now from a vertical scale, right here says 1. So every centimeter is 1. So it's 1, 2, 3, 4, 5. That's the highest point. Then it says negative 1, negative 2, negative 3, negative 4. Let me take these out now. That's my scale. Let's put on the graph in red. Let's put on the points in red. That's my x and my y-axis, right? What are the points again? So negative 2, 5, and 4, 5. Negative 2, 5, and 4, 5. Negative 2, negative 2, 5. Maybe it's darker so you can see that thicker. So negative 2 up to 5. That's right here. And 4, 5. 4, 5 up to here. That's 2 points so far. Let's take 2 more. Then 0, negative 1, and 3. No, sorry. negative 1, 0, and 3, 0. That's on the x-axis, those are the roots. Negative 1, 0 is here, and 3, 0 is here. Next points. 0, negative 3, and 2, negative 3. 0, negative 3, and 2, negative 3. So 0, negative 3 is here, and 2, negative 3 is here. We have the vertex point in the middle, which is 1, negative 4. 1, negative 4 is here. And this is going to be my line of symmetry. It's a different color. Right through here. It's my axis of symmetry. Let's draw the graph in red. So just smooth curve now through these points. Something like that. And that's a graph. That's a sketch of a graph. You can write on it, sketch off, and write it. Alright, what does they wanted us to do? Sketch it, and then say draw a smooth curve through the points, right? It's a complete the sentences using the information from the graph. The values of x here, function equal, those are the roots, you know. You put the equation, you get in the roots. The value of x where the function equals 0. It's in the table as well. See where the function equals 0 is negative 1 and 3. You could also see it on the graph down here, the roots. Negative 1 and 3. So negative 1 and 3. Negative 1 and 3. And this one said the minimum value of the function. That's the lowest y value. And put the red roots up here. This question is talking about the roots. The minimum value of the function is the lowest y value of the function, which is this. Negative 4. Negative 4. This one now, the equilibrium line of symmetry of the graph is x equal this vertical line. Is x equals the y value, the x value it passed through is 1. X equals 1 that. X equals 1 is that vertical line of symmetry. This question is looking for x equals 1. Answer, this is done. But I did that. But I good at that.
Yes, sir.
Yes, sir.
On to
Yes,
the next
sir.
one. On to the next one. Let's do the next one. More maths equals better maths. Let's do the next one. What was the next paper I sent you? What was the next paper? Remember? Let me see if I can see it. This is the next one I sent. This one. 2017. I gave you these questions to do. Right, let's do them. More maths equals better maths. You're not going to take an hour to do this. I think 10 minutes. 20 minutes to more. Shouldn't take more than 20 minutes to do this. Alright, factorize completely. So here is two terms. Say a minus, I'm thinking about the difference of 2 squared just in case, but initially it's just a common factor. So if we look at these two, highest common factor initially is just a 6. If you look at the numerals, the highest common factor first is 6 with the numerals. With the y terms is y. Y. And that's it. Highest common factor is 6y. If I factor 6y out of this, I left with a y. If I factor 6 out of this negative 18, I left with a negative 3. This y is already factored out. What I have left in there is this x. X. If you're not sure, you can expand this back. If I multiply this by this again, I'm going to get back that. If I multiply this by this, I'm going to get back that. So I know that it is correct. Alright. That's the first one. Next one is this to factorize. Remember, that's the difference of two squares we have now, because that's a perfect square and that's a perfect square. When that's the difference of two squares, this should be, this is a perfect square, is 2m all squared, minus, this is a perfect square, is 1 squared. So you factorize the difference of two squares, remember it becomes the difference of the numbers, which is 2m minus 1, and then the sum of the numbers is 2m plus 1, and that is it. 2m minus 1, 2m plus 1. Better go to that?
Yes, sir.
Alright. Now
Yes,
we come
sir.
to this quadratic. Again, these n values are prime, so this can be done quickly like just doing them in the board. That's for another day. I'll show you that another day. I'm going to follow the process of splitting the middle terms. I'm going to multiply two n values first. It's 2 times negative 2. That's equal to negative 4. One factor of negative 4 that add to this middle term of negative 3. Let's find it down here. Since I want factors of this negative number, one will be positive and one will be negative. Since I want the sum to be negative, I'm going to make the larger of the two factors negative. First two factors of 4 is 1 and 4. Make the larger one, which is this, have the same sign as that, which is minus. And the smaller one positive. And when I add these two, when I add this and this, it comes out to be negative 3. So I've already found the factors that add to negative 3 up here. 1 and negative 3. It means that I'm going to split this minus 3x into minus 1 into plus 1x minus 4x. I can put the minus 4x in front. Split it using those two factors. Alright? That's the process. So this now is going to become, let's go back for the black or blue. This remains 2x squared, 2t squared. Then now, I'm going to split this using these two. I'm going to put this one in front because it will factorize nicely with the 2. So I'm going to put it as minus 4t and then plus 1t plus 1t. I don't have to put the 1 there, but I just let me put it still. And then I get back minus 2 up here. Minus 2. And I always check if I split this into would give about this middle term. Yes. Negative 4 plus 1 is negative 3. There you go. Highest common factor in the first two terms is 2t. 2t out of this leaves it with a t. 2t out of this leaves it a negative 2. Remember now that you have to get the same thing in the bracket over here. So the same thing to do is put by the t minus 2 in the bracket. There you look. A 1t, and you factor in the t, you must factor out a positive 1. Or you can say negative 2 divided by negative 2 is positive 1. So the number becomes a positive 1. Then now you're connecting the t minus 2 using 2t plus 1. Because t minus 2 is now a common factor. So you're going to get 2t plus 1 times t minus 2. That is it. But alright. Could have just written this from this to this straight, without all that work, but we will practice that after we master this. I'll show you how to do it. Quick and fast. But I go to that so far?
Yes, sir.
Yes, sir.
Alright.
Yes, sir.
Did I tell you to do this one? I'll leave this one another day. Let's focus on the quadratics. I'll deal with this another time. Those algebraic fractions, alright? We deal with those another time. We're not focusing on that now. We're focusing on our quadratics and our factorization. Let's see there's another quadratic on this paper. Number 9. No, that was it. That's all they were supposed to do on that paper.
Yes, sir.
Alright, good. Well, that is it for today, guys. That is it for today. Nice, quick session. All you need to do now is go back, redo the questions. If you did not do it, go and do it now. If you did it and you got something wrong, you go and do it over. Moving on to new material tomorrow, guys. We're going to be doing simultaneous equations leading to a quadratic equation. I think we're also going to be doing finding the roots from a quadratic equation. Now find using the roots to find a quadratic equation. I think that's what we're doing tomorrow. I think this week is gonna be the last week of me teaching the quadratics as a topic. Going forward, we're gonna practicing. So I think next week we'll be moving on to a new topic altogether. So I think tomorrow's class is the last class on quadratics. Alright? Simultaneous equation leading to a quadratic equation and finding the quadratic function from the roots. That's what we're doing in class this week. Alright, and we shall continue the program, guys. So see you all. What I tell you, please don't be lazy. Put in the work, you'll get the results. Right? Remember, this subject is a one subject. Just that you have to put in the work to get the one. Alright, one can't make itself. We have to make the ones. Alright, guys, more maths equals better maths. All mathematical principles can only be fully understood by solving many questions. Meaning, if you really want to fully understand these things, you have to really solve a lot of questions. A lot of questions. The more questions you solve, the better. The more questions you do, the better you understand it. And the more it will retain, the more you retain the know-how for doing these questions. Alright, guys, I'll see you in class tomorrow on Monday. Bye. Have a good day.
All right, sir. You too.
Bye.
Yes, sir.
Bye.
Yes, sir.